Question number 11. A diver launches herself off a springboard. The height of the diver in meters above the pool t seconds after the launch can be modeled by the following function. ht is equal to 5t minus 10t squared plus 10. A. How high is the springboard? Let's first understand. We have a springboard here and it is above the water. There is an equation ht is equal to 5t minus 10t squared plus 10. This equation tells us the height of the diver at t seconds. So, when there is no diver here, the time is 0. So, we need to find the height when there is no diver, basically the constant height of the springboard diver. At time 0, height will be 5 into 8 minus 10 into 0 plus 10. And we have height is equal to 0. That answers part A. Then comes part B. Part B says use the model to find the time at which the diver hits the water. Now, in the given case scenario, we need to find when the diver hits the water. So, when the diver hits the water, the height will be equal to 0, height above the water. So, we can use this equation and we can equate the height equal to 0. So, we put 0 here. So, we have 5t minus 10t squared plus 10 is equal to 0. And we solve this in order to find the time when the diver hits the water. We can divide by 5 to simplify this. So we have t minus 2t squared plus 2 is equal to 0. We can rearrange it. Minus 2t squared plus t plus 2 is equal to 0. We can solve this equation by using the formula minus b plus or minus square root of b squared minus 4ac all divided by 2a. So minus b will be the coefficient of t, which is 1. So minus 1 plus or minus square root of b squared, which is 1 squared, minus 4 into a into c. All of that divided by 2 into a. So simplifying this further, we have 1 plus 4 to the 8, 8 to the 16. So 1 plus 16 divided by negative 4. So we have minus 1 plus or minus root of 17 divided by minus 4. And this gives us the value of time. Let's calculate time in decimals. So we have minus 1 plus square root of 17 all divided by negative 4. And this gives us negative 0.78. Time cannot be negative, so this value is ruled out. We can find the other value, minus 1 minus the square root of 17 all divided by negative 4. And this gives us 1.28 seconds. So that answers part B. Moving on to part C, the question says, moving on to part C, we need to rearrange it in the form of completing the square. So this is the required format, which is of the completing square. So let's write the equation for part C. We have minus 10t squared plus 5t plus 10. So we can pull out the negative 10 outside, because when we do completing the square, we need to have a 1 as a coefficient of the t square here. If the coefficient is something other than 1, which is in this case is negative 10, we pull it out as a common factor from the first and the second term. Now the second term doesn't have a 10, it has a 5. So we can multiply the second term by 2 divided by 2, which is in fact just multiplying by 1, but 5 into 2 in the numerator will give us 10. So minus 10 t squared plus 5 into 2 by 2 t plus 10. So we have minus 10 t squared plus 10 t divided by 2 plus 10. So now we can pull out the negative 10 common out. So negative 10 is pulled out. We have t squared minus half t left here. And the plus 10 is outside as it is. Now we will do completing the square for this bracket. So we write the minus 10 outside as it is. For completing the square, we take half the coefficient of t here. So half of half is 1 by 4. So t minus 1 by 4 and complete the square. Now this number, I will subtract the square of it outside the bracket. So minus 1 by 4 squared, close bracket, write the 10 as it is. So we have minus 10 into t minus quarter minus 1 by 16 plus 10. Now we multiply the 10 back. So we have minus 10 into t minus 1 by 4 squared plus 10 divided by 16 plus 10. So that simplifies to minus 10 t minus 1 by 4 squared plus, so we have 10 divided by 16, 10 divided by 16, add 10, which is 10.625. So in this format, the positive term is written first. So A represents the 10.625. So we'll start 10.625 minus 10 into t minus quarter, the whole squared. Give the values of A, B and C. So my A is 10.625, B is negative 10 and C is a quarter. Here the minus sign is already taken care of. So when I'm writing the value of C, I will just write the quarter and not with the minus sign. That answers part C. For part D, using your answer to part C or otherwise find the maximum height of the diver and the time at which this maximum height is reached. So we can find maximum or minimum using this value of completing the square. So when we complete the square, we can get the maximum or the minimum value. So how do we get it? We have minus 10 into t minus a quarter squared plus 10.625. So the maximum or the minimum is represented by coordinates. To find the x coordinate, take this bracket and equate it to 0. So t minus a quarter is equal to 0. Therefore t is equal to 1/4. And for finding the y value, we will write the value outside as it is. So that is your y value for the maximum. So this is your x and this is your y. Moving on to the next question. Question number 12. For equation f of x is equal to 4k x squared plus 4k plus 2 into x plus 1, where k is a real constant, find the discriminant. So discriminant is equal to b squared minus 4ac. So what's my a, b and c? A is the coefficient of x squared, b is the coefficient of x, and c is the constant. So here is my a, b and c. Hence I can find the discriminant b squared minus 4ac by 4k plus 2 squared. This is my b squared minus 4 into my a into my c. So this is expanding by a plus b the whole square identity. It expands to gives a square plus 2ab plus b squared. So that is 4k squared will give me 16k squared plus 2 into a into b will give you 2 2s are 4, 4 4s are 16k plus 4 minus 16k. So these two cancel out and I have 16k squared plus 4. So B says by simplifying your answer, and which we have already simplified here, or otherwise prove that f of x has two distinct real roots. Now for two distinct real roots, our value of b square minus 4ac must be greater than 0. So let's check out. This is the value of b squared minus 4ac we got. Let's see if this is greater than 0. So we have 16k squared plus 4. Now a can be, the value of k is any real constant. It is given here that k is any real constant. If k is positive, then definitely this whole expression is going to be greater than 0. The other option is if k is negative. If k is negative, then also k square will be positive. So then also this whole expression will be greater than 0. The third option is that k is 0. If k is 0, so for example, if I have 16 into 0 squared plus 4, then also this is value plus 4, which is greater than 0. So the value for b square minus 4ac is greater than 0 in all conditions. Therefore, we have two distinct real roots. Therefore, we have two distinct real roots. That answers part B. Moving on to part C, it says, explain why f of x cannot have two distinct real roots when k is 0. So our f of x is 4kx squared plus 4k plus 2 x plus 1. So if k is 0, what happens? The first term becomes 0. The second term, we have 0 plus 2 into x plus 1, which gives us 2x plus 1. Now 2x plus 1 is equation of a straight line. So this is a linear equation, and hence we cannot have the value of k is equal to 0. Therefore, value of k cannot be equal to 0. Moving on to the last question, which is 13. Find all the roots of the function r of x is equal to x to the power of 8 minus 17x to the power of 4 plus 16. Now here we will use substitution. We will substitute x to the power of 4 as y. Now x to the power of 8 can also be written as x to the power of 4 the whole squared minus 17 into x to the power of 4 plus 16. So both these can be substituted for a variable y. So I have y squared minus 17y plus 16. Now my product is positive 16. My sum is negative 17. So my numbers are minus 16 and minus 1. So my factors are y minus 16 into y minus 1. Now since I want to find the roots, I have to equate this to 0. So I have y minus 16 is equal to 0, y minus 1 is equal to 0. Therefore y is equal to 16, y is equal to 1. But originally I had no y. So I will go and resubstitute what was the first value where I substituted y. So this was x to the power of 4. So resubstituting, I have x to the power of 4 is equal to 16 and x to the power of 4 is equal to 1. Now what number to the power of 4 can give me 16? 2 to the power of 4 is equal to 16. But if I have negative 2 also, negative 2 to the power, negative number to any even power also gives me a positive value. So my values can be 2 and negative 2 for this one. And here x to the power of what value gives me 1? So 1 to the power of 4 gives me 1. And also negative 1 to the power of 4 will give me 1. So I have values 1 and negative 1. And that answers question number 13.